Welcome to the technical demonstration of EGI's recommended workflow for source estimation using GeoSource 3.0 Research Basic. Please note that this is a guideline for the workflow. Each time you start with a new file, your steps may change based on the data in your file. If you have questions, please contact support. Open a file in NetStation Review that has been prepared for source localization. The data needs to be clean of all artifacts, including DC offset, and have a good signal-to-noise ratio. Choose the default keyboard set. This has the controls set up for best use with GeoSource 3.0 research. Assess your data to form a hypothesis for results in the source estimation. Open up a workspace that has been created for EEG source estimation. This workspace has a chart, a plot, a butterfly, and a map view. Click the P key on the keyboard to snap to peak so that the time sync marker is placed on the maximum voltage of this event. Lock the color palette range for the topo map to the peak. Look at plot and map to get an idea of the location and orientation of the source or sources that may be contributing to the scalp topography. The dipolar activation has a positive and negative field projection on the scalp. The source would be located in the neutral gradient somewhere in between. Click on Chart View to make it active. The reciprocity visualization environment will pull the EEG data from this default chart view to make the calculations. It will send the following information: data for all the sensors. Sensors marked bad will not be used to compute the scalp interpolation or source calculations. All the viewer filters, and the mean correction setting. Click the View button in the bottom tray to bring back your viewing options. Click on the Reciprocity Viewer icon in your Views menu. Select the options for the imaging specification. Choose your constraint for the inverse algorithm. S. Loretta is most constrained, so we reserve that algorithm for use with the most constrained head model, which would be an individual head model. GeoSource is using an atlas here, so we're going to stay with Loretta. Choose your regularization level. Start with values near the provided default. I'm going to keep the selection to -3. This scale uses scientific notation so that 10 to the -1 is more regularization than 10 to the -3. Regularization is a spatial smoothing of the data, so it provides additional smoothing constraints on your results so that you can reduce variance in your data and help the signal-to-noise ratio. Choose your forward model calculation method. There's the finite difference method, a realistic model, and the spherical or Sen-Stokes shell model. GeoSource Basic provides Atlas head models. There are 6 Atlas head models provided in GeoSource Basic. Only the Atlas head models that correspond to the appropriate channel count that fits the EEG you have loaded in Review will be shown. For example, the file loaded in Review right now has 256 channels. Therefore, the Atlas models for 0 to 2 years and 2 to 9 years that have 128 channels will not be shown. There is an example individual head model that is provided as a demonstration of how the RVE would visualize an individual head model. It is not recommended to use this model for analysis. The EEG and the individual head model have to be from the same person in order to interpret the source results. The Atlas models are designed so they can be used with EEG from different people. Therefore, they are inherently generic in a way that allows you to compare source estimations generated with different models. I'm going to choose the 32-year-old male Atlas for this data. Click Launch. The Reciprocity Visualization Environment, or RVE, will load in a separate window. You can see the icon for the RVE down in the dock. Once it is loaded, you can organize your screen to better fit all of your windows. We do not recommend updating your workspace once you have the RVE open. NetStation will then try to launch RVE every time you access the workspace, which will not allow you time to provide user input before it launches. The head model is listed at the top of the window along with the file name. The left column has all of the function controls for the view you have in the center. To change your view to another option, you can use the column on the right. We recommend starting with the scalp topography exploration. Use the 3D topo map to assess your data and further your understanding of the data in the 3D space. Hold down the left click button and drag to view different sides of the 3D topo map. Click on View in the toolbar to use different default controls to change the viewing angle. You can zoom in and out by holding down the right click button and dragging the mouse. You can move the images on the screen by holding the right click button and the Shift key and then dragging the image. You can see how the topo map changes over time by using the left and right arrow keys. This will page through the EEG so that you can see the smooth change over time. Next, click on Tissue Segmentation to review the anatomy of the head model. Change the opacity of the MR image volume in the view controls on the left. Click on the Atlas Electrophysics Review to evaluate the lead field matrix for each voxel. Shift and click on a voxel in the 2D MRI view in the bottom views to select a voxel. Choose which lead field you would like to review by selecting X, Y, or Z in the view controls. Click on Atlas Triples Sources to view the source results. Now you see the scalp topography on the left with the volume slice view on the right. Along the bottom, we can see the 2D MRI slices that are used in the Atlas model. Make sure the time sync marker is set to the peak of the event in the EEG. Next, we're going to set the color palette of the source results so that the maximum voltage in the data is locked to the maximum color intensity in the result, the brightest yellow. So now I will only see this bright yellow color when I'm at the maximum, and my data set will be represented with a color palette relative to that maximum. When we lock the palette, we can evaluate the source results with a color palette that will be consistent across time points. The EEG data used to calculate these results is coming from the default chart view in Review. You can see any viewer filters that are being applied to this data by looking here underneath the color palette. You can see the box is checked next to Snap to Maximum as the default. The source scenes will show you the MRI slices that have voxels with the maximum values. Uncheck this box so that you can manipulate the view without this feature. Assess your results. The color within each voxel represents the level of current density at that point in time, yellow being the maximum current density. Values in source estimation represent the relative strength of a dipole required to reconstruct the scalp topography in question. Use the same controls as in the topography view to move the volume slice view around to view the results from different angles. Use the view controls in the top left to change the opacity of the scalp mesh or the size of the electrodes. The pointer feature in the 3D topo map will point to the location of the crosshairs in the 2D MRI image. Use your click and drag on the 2D MRI slices to move through different slices. You can change the source threshold to focus on voxels with the highest intensity results. Change the source opacity to see the different areas of intensity. Click back to review and change your timescale in the chart to 1:1. Now you can evaluate the temporal stability. Move the time sync marker earlier in time, before the event, to look at how this event starts. Navigate through time using the left and right arrow keyboard shortcuts to move along sample by sample. How stable is this source over time? Does it correlate with the smoothness of the scalp topography? If it jumps around or the map is not smooth, rule out artifact by looking at the scalp data and reviewing each channel, not just the subset in a montage. Next, evaluate the vectors of the source result. Each voxel has a dipole with a vector that has one end pointing to the negative field, or blue, and one end pointing to the positive field, or red. The direction of the negative vector end of the dipole should reflect a negative projection of that dipole on the scalp topography. Compare the orientation vectors to the vectors in the single direction from the MRI view. The MRI view shows the vector direction as always pointing toward the positive end of the vector. Therefore, the vectors in the 2D image should be pointing in the same direction as the red end of the vectors in the 3D image. The vectors can be used to assess the level of regularization. Vectors should agree coherently with the scalp topography, meaning that they represent the variation in scalp topography accurately. Click back to review and view a different category of EEG to look at another category of EEG in the RBE. From review, you can also load another imaging specification into the RBE. Click on the Reciprocity Viewer icon again and choose your second imaging specification. You can choose up to 4 imaging specifications for each head model you've loaded. You can load up to 2 head models for a total of 8 imaging specifications loaded at once in the RBE. Choose a different head model. I'm going to choose the 40-year-old male for my second head model. Lock the palette and compare the results with this model to the previous model. Switch back to the other head model. Click on File, Switch Head Model, and select the 32-year-old male. Return to review and launch the RBE one more time and add another imaging specification to the 32-year-old male atlas model. Choose LoRa -3 FDM. Lock the palette and compare the results. Switch back to Loretta -3 FDM under Imaging Spec by clicking the drop-down next to Method. It will only allow you to change to other imaging specs you have loaded through review. To close a spec, load the spec in the RBE and click Close Current Spec. Make sure you lock the palette again. You will need to lock the palette every time you switch to a new imaging specification. It will stay locked to a specific range of values across different imaging specs even if you switch to a new one. For example, it is locked to the results for LoRa -3 FDM. Reset it to this new imaging spec by unchecking the box, moving the time sync marker to the peak, or just nudging it back and forth so you know the RBE is updated, and then checking the box again. Create a collection of different dipole groups by adding a source collection. You can use the source threshold to help decide which dipoles you'd like to select. Under Triples Collections, click on All Sources, select New Triples Collection, enter a collection name. When you choose the name for the source collection, you can, for example, give it the name of a patient or condition within your study. Then the dipole source groups can have more specific names, like left anterior temporal or right motor cortex. Select the voxels in the 2D MRI slices to add as a dipole source group. Shift and click to select one voxel at a time, Shift, click, and drag to select multiple voxels. If you Command-click on a voxel, this selects one voxel and then allows you to threshold the addition of voxels around it. For example, if you clicked on a dipole with the value of 10 microamperes and typed in 50, it would select all the dipoles connected to the original that were within plus or minus 50% of that original value. So values between 5 and 15 microamperes. Click the Add Selection button and then choose to add these dipoles to a new or existing dipole group. Here we're going to choose the new group. Into our source group name, select the color with which this new selection of dipoles will be highlighted. Clicking the checkbox next to the dipole group will show or hide the dipole group in the volume view. You can edit and delete groups using the buttons in the menu. View the scalp field voltage of the group projection only versus the entire EEG at that point in time. In the left column under GeoSource and Topographies, click on Group Projection under the Sensor Voltage field and under the Scalp Voltage field. Notice the menu at the top now says Triples Lead Field Projection to reflect the data you're seeing on the scalp mesh. This is the projection of the dipole group you have selected in the triples collections. Click the EEG category button to display the EEG from the category you are viewing in Review. Thank you for watching the technical demonstration of GeoSource 3.0 Research Basic. If you have further questions, please contact EGI support.